So aside from product configurators, there's also drawing automation that we can do inside of iLogic. Let's go back over here to Inventor. So if I go through this process, and let me actually switch this over. I'm going to switch this over to Inventor 2019. I need to rapidly do this because we have a lot more information to cover here, and I want to open it up for questions here in a moment as well. All right, so with the product configurators, there's a lot of information that is needed to be taken into consideration. If you need to be familiar with parameters, naming conventions for different parameters, so that way we can easily identify the components that are needed to be associated to a particular configuration. So if you're not taking those things into consideration as of yet, certainly a topic that should be addressed. Okay. So, so another product configurator that I have available, if I want to start up a new file here, I have this LSC, this Launch System Configurator. So I have this as an assembly template that I'm going to fire up here. And to kind of quickly demonstrate what that does and what a product configurator is, simply, it's a means for us to input information and based upon that input information, derive or arrive at a particular configuration, okay? So if I bring up my LSC again, and I just plug in some values that I'm quite familiar with to make this work appropriately, what do I want to do in terms of developing my rocket here? I want to put in a height, a width, where am I going to send it to? Once I hit accept, then I'm going to get some options as to which one I want to build. I'm going to say this, I'm going to build an Atlas rocket with a few boosters here, and I'm going to say build, and then what it's going to do is it's going to create that rocket for me. So that's exactly what a configurator does. So it went out, it grabbed different files from my directory, brought them into the context of this assembly, and then it constrained them together based upon business logic. So no matter what I do over and over and over again, it's always going to build it appropriately. It's going to build whatever my product might be based upon that logic. Okay. So in terms of excuse me, in terms of drawing automation, so now that I have a product, now I need to develop the 2D documentation that's associated to this. How do I go about doing that? Quite simply, if I save this, I'm going to save this first, and let's save this here, and I'll call this, well, we'll say assembly 1. Okay, so assembly 1 is saved, and then I have this iLogic rule called create drawing. So if I run this guy, what it's going to do is it's going to say, okay, you want to create a drawing? What are you going to create a drawing of? Make sure you use the correct template, because as I'll show you here in a moment, I actually have iLogic rules inside of the drawing that allow me to generate all the different sheets and views and whatnot. So now that I have the drawing created, it's asking me, do I want to open up the drawing now? And this is iLogic code that I developed to prompt end users to do certain things within the process. Okay, and then I'm going to run this rule, and it's going to create the different sheets that I need. It's going to create the different views that are necessary. It's going to add balloons. It's going to add a parts list, and it's even going to add a few dimensions to my drawing automatically with iLogic. This is so amazing, just to be able to take an assembly configuration and then output the necessary 2D documentation consistently, repetitively, with a high level of quality without any manual interaction. I mean, a lot of companies spend a great deal of time just going through this process, and now imagine being able to expedite that process as best you can. So these different iLogic rules, once again, are structured and organized in such a way because of how Inventor behaves and how it interacts and what are the requirements for different things. when developing a drawing, we know that we have to create numerous sheets to represent the information. On those sheets, we have to have different views. In those views, we need to show specific component visibility. Some things need to be turned on, some things need to be turned off. We always need a parts list, particularly if we're dealing with in an assembly. We need to know quantities and part numbers and descriptions. We need to itemize or balloon out our different components, and we need to throw down different dimensions so we know the scale and the depth and the scope of what it is that we're trying to deal with. And inside of Inventor, we can leverage sketch symbols, so those are important as well sometimes. So all these are necessary components of developing a drawing, so we need to account for those inside of our iLogic rules. You know, as an example, looking at create sheets, you know, this is the rule that I created just to create a series of sheets. What do we want to name the sheets? What is the sheet size? What is the sheet orientation? You know, those types of things we have to account for whenever we create a sheet. And I can go into more depth at some other time about what it takes to create the logic for dealing with drawings as well.